Welcome back to AI on AI, where we decode cutting-edge research for both the boardroom and the data center. Grab your favorite beverage. This is going to be a ride.
Delighted to be here. I keep telling exec teams that retrieval augmented generation, or RAG, is today's steam engine moment, but this new Graph-R1 framework, well, that's more like electrification.
Electrification is right. From a technical lens, Graph-R1 fuses hypergraph structures with end-to-end reinforcement learning. Think AlphaGo, but instead of a Go board, you have a dynamic knowledge base.
Exactly. And because it's a hypergraph, each hyperedge can connect n entities, not just two, which captures higher-order semantics that a flat chunk-based store misses completely.
Let me jump in. Enterprises I advise are drowning in PDFs and wiki pages. Graph-R1's lightweight extraction slashes ingestion costs by about 30+% versus vanilla GraphRag pipelines. That's huge for scalability budgets.
True, though we can't ignore governance. When you encode relationships at that granular level, provenance tagging becomes more complex. If the agent hallucinates, auditors want a breadcrumb trail.
Good point. Let's unpack the architecture first. Hypergraph, multi-turn reasoning, GRPO, maybe set the scene for listeners.
Sure. Picture 3 layers. 1. Build a hypergraph where each fact is an n-ary tuple. 2. Use a policy network, an LLM in disguise, to decide think, query, retrieve, or answer. 3. Optimize the whole loop with group relative policy optimization, or GRPO, which stabilizes gradient updates by clipping relative to a reference policy.
And the retrieval step is dual path. There's entity-centric lookup and direct hyperedge retrieval. Then ranks are fused with reciprocal rank aggregation, sort of like combining Google's PageRank with a library index card.
The business value? Faster, more accurate answers without relying on gigantic context windows. One insurance client saw question resolution times drop almost 40% after moving from chunk RAG to a graph prototype.
That's the 80-20 rule in action. 20% of architectural change, delivering 80% of downstream impact.
Building on that, the multi-turn agentic loop is critical. Early RAG systems tried one-shot retrieval. Grab everything once, then pray. Here, the agent revisits the graph, pruning irrelevant branches each step. It's like a consultant who keeps asking clarifying questions rather than presenting a half-baked slide deck. And mathematically, that reduces entropy faster per token retrieved. The paper's Lyapunov analysis shows mutual information grows strictly faster with multi-turn.
Yet the contrarian in me wonders, are we trading latency for accuracy? Reinforcement loops can add seconds. In customer-facing chat, that's noticeable.
Surprisingly, no, because the graph offers dense edges, each turn pulls smaller snippets. Response length actually shrinks. Their benchmarks show roughly 1.2 to 1.5k tokens versus 3k in chunk systems, so wall clock stays competitive.
Less is more, as Mies van der Rohe would say. Quick poll, what was the most surprising experimental result for you?
For me, the ablation where they yanked RL, performance cratered. It proves the structure alone isn't magic. Policy learning is the secret sauce. I was stunned by the out-of-distribution tests. The F1 ratio stayed above 85%, even when the training domain shifted, music to a CIO's ears when you're rolling out to new verticals.
I'll add a macro view. We're inching toward knowledge operating systems where retrieval, reasoning, and governance are natively intertwined. That's a strategic moat, not just a marginal feature.
But let's address the elephant, data lineage. Hypergraphs can encode provenance per hyperedge, but few teams pipe that into dashboards. Without that, regulators may balk.
True, yet the framework gives you the hooks. Each hyperedge stores an extraction segment and a coherence score. Plug that into an audit layer, and you've got end-to-end traceability.
Sounds like plug-and-play compliance, if you actually plug it. Okay, I want a technical deep dive. GRPO versus PPO versus classic reinforce. Why choose GRPO?
GRPO groups trajectories and normalizes rewards across them. That curbs variance without the heavy-handed KL penalties PPO uses. Empirically, they hit higher F1 in fewer epochs. Call it a Goldilocks optimizer.
And it meshes nicely with graph traversal. You can batch similar query paths together, which speeds up GPU utilization.
From the cost side, fewer epochs equals shorter training cycles. In a POC we ran, training time dropped by roughly 25% when we ported a PPO agent to GRPO.
Efficiency is great, but we should also consider fairness. RL agents can over-optimize on popular graph paths, sidelining minority data. Stratified sampling during training might mitigate that.
Love that nuance. Now a real-world analogy. Anyone?
Think of chunk RAG as flipping through a phone book. Hypergraph RAG is like Google Maps with turn-by-turn navigation. Graph-R1 adds Waze-style live traffic updates, so your route adapts in real time.
Nice. And remember Edison's quote, "Vision without execution is hallucination." Graph-R1 literally suppresses hallucination by binding answers to graph evidence.
Ha, pun intended. One quick algorithmic nugget, the reciprocal rank aggregation uses WAR-V plus RH. That rewards facts found in both entity and hyperedge searches. Simple yet elegant. And it's deterministic, which business leaders love. No random seed madness during audits.
But deterministic ranking can entrench outdated facts if the graph isn't refreshed. A nightly incremental extractor is vital.
We're nearing the last stretch. Let's hit future directions.
Technically, I see graph neural networks layered on top, so the agent not only retrieves edges, but updates embeddings online, closing the representation gap.
Plus, multimodal hypergraphs. Imagine linking text, images, and tables for, say, pharmaceutical R&D. You'd accelerate compound discovery workflows.
Strategically, expect RAGOps teams the way we have MLOps now, dedicated roles for graph maintenance, policy tuning, and compliance.
And don't underestimate small model deployments. Their 3B parameter run punched way above weight. Edge inference on private data centers is in sight.
I'll throw in the curveball, responsible decommissioning. As graphs evolve, how do you retire stale hyperedges without breaking downstream agents? We need sunset protocols.
Sunset protocols. Love the unexpected angle. All right, lightning round. Single sentence advice to leaders looking at Graph-R1.
Prototype fast, but budget time for extraction quality. It pays dividends.
Treat RL rewards as product requirements. Vague rewards equal vague models. Align graph schemas with business taxonomies early. Remapping later is painful.
Bake in provenance tracking day one. Retrofits are ugly.
Remember Peter Drucker, strategy is a commodity, execution is an art. Graph-R1 gives you new brushes, but you still need skilled painters.
Brilliant. Folks, that's a wrap. If today's episode sparked ideas or polite panic, share it with a colleague. Until next time, keep asking better questions so your AI can give better answers. Welcome back for part 2. This is the nuts and bolts segment where we roll up our sleeves and peek under Graph-R1's hood.
Let's start with extraction. The paper swaps heavyweight triple extraction for a lean n-ary prompt. They hit roughly 5.7 seconds per 1,000 tokens, which is, well, half a coffee break compared with classic GraphRag.
And the secret is, they bypass confidence scoring during build time. Instead, they push coherence assessment into retrieval. That offloads compute and keeps the hypergraph lightweight. Fewer embeddings, faster lookups.
Business folks always ask, what's the install path? Picture a 3-step pipeline. 1, spin up a GPU for one-shot extraction. 2, push hyperedges into a vector DB, Milvus, or PG vector both work. And 3, schedule nightlies for incremental ingest. Minimum viable stack in under a week.
We piloted that with a telco's troubleshooting knowledge base. Tickets dropped 28% because agents got root cause answers in 2 hops, not 15 wiki scrolls.
But don't gloss over schema design. If your domain lacks clear entity types, the n-ary extractor can spew noisy relations. We saw this in legal briefs. Ambiguous party entities doubled edge count and muddied retrieval.
Good call. The paper's heuristic is to embed both entity and relation tokens with the same encoder, BG large v1.5, so semantically similar edges cluster even if names vary.
Diving deeper, dual path retrieval matters. Entity path uses top K nearest neighbors on aggregated entity embeddings. HyperEdge path does direct edge similarity, and then they fuse ranks with one RV plus RH. It's OK log K thanks to heap ops, so latency stays tame.
I like to explain that to execs with a dating app analogy. You match on who you are, entities, and what you like to do together, hyperedges. Combining both gives fewer bad coffee dates, or irrelevant docs.
Ha! And because turns are multi-step, the agent can say, not a fit, swipe again. That iterative pruning kept context windows below 1.5K tokens, so even a 1.5B model can play.
Speaking of models, training with Geo took 3 epochs on 4x A100s. They batch trajectories into groups, so variance drops. Think of it as wisdom of crowds for gradients.
Exactly, and the reward split, 0.5 points per well-formed step, encourages disciplined agent syntax. Without it, we found the LLM drifted into streaming its inner monologue. Entertaining, yes. Audit-friendly, no.
Implementation tip. Log the state action pairs in a structured store, Parquet or Arrow. That lets you replay trajectories for fine-grained failure analysis.
On the business side, replay is gold for continuous improvement loops. One retail client used trajectory heat maps to spot stale product attributes and refresh queues overnight. Result, search-to-purchase funnel improved by roughly a fifth.
And let's not forget cost. Because generation cost is effectively zero after training, the agent sits inside the same LLM, you avoid per-query external API fees. CFOs smile at that.
Contrarian moment. Zero marginal cost can breed complacency. If retrieval is free, teams may stop pruning the graph, and bloat sneaks back in. Governance charters should set max graph size per domain.
Totally. Another engineering pattern is progressive sampling. Start with k equals 3, escalate if answer confidence ta. That keeps latency predictable.
Futures? I see on-device embedding reindexing. With Vice's IVF-PQR, you can refresh vectors without downtime, crucial for environments like hedge funds where seconds matter.
Plus, cross-modal edges. We're adding ICD-10 codes linked to X-ray images in a hospital rollout. Early tests cut radiologist lookup time by nearly a third.
Wrapping up, here's the distilled playbook for business leaders. Align reward metrics with KPIs, invest in schema governance early, and iterate fast. You'll see ROI in weeks, not quarters.
Perfect landing strip. That's the deep dive, implementation pitfalls, and real gains. Share this episode with your DevOps and strategy teams, and we'll see you on the next AI on AI. Folks, time to land the plane. Let's pin down the takeaways so listeners can walk into tomorrow's stand-up with talking points.
Technically, the headline is that Graph-R1 marries hypergraph retrieval with GRPO, so structure plus policy gradient equals tighter evidence alignment and roughly 20-point F1 gains over chunk-only baselines.
Right, and the lightweight N-area extractor is the unsung hero. By dodging per-edge confidence scoring, we slice construction cost in half, yet keep semantic coverage. Measure what matters, as Drucker would say.
Building on that, governance is your guardrail. Without periodic graph pruning, you'll hit the memory wall and the agent's precision erodes. Think of it like tending a bonsai, not planting a jungle.
From the strategy chair, 3 KPIs popped out: ticket deflection, search to purchase lift, and expert hours saved. Each maps cleanly to the agent's reward channels, so your finance team sees a straight line from model metrics to business value.
And remember the 80-20 rule. 20% of your ontology drives 80% of queries, so pilot there first. One logistics firm started with delay causality edges and shaved a quarter off average resolution time in a month.
Future-wise, multimodal hyperedges, images, sensor logs, code snippets will push retrieval into a knowledge fabric, not just text. GRPO is agnostic, so the policy just needs new embeddings.
Small but critical caveat: retrieval latency hinges on vector index hygiene. Run nightly IVF-PQR refreshes, or, well, your think, retrieve, rethink loop will start to feel like dial-up.
Ha, cue the nostalgic modem noise, but seriously, allocate a slice of your sprint to monitoring average content length. When it creeps above 1.5K tokens, that's your early warning.
One contrarian thought: Everyone's chasing bigger base models. Yet our telco case showed a 1.5B parameter agent beating a 70B chunk baseline because structure trumps sheer size. It's not the dog in the fight. You know the rest.
Exactly, and that's empowering for mid-size orgs. Graph-R1 lets you punch above your weight without renting a data center-sized wallet.
Love it. So the cheat sheet: lightweight hypergraph, dual path retrieval, GRPO training, strict reward hygiene, and relentless pruning. Execute those and you're in the next league. Big thanks to everyone. This was fast, fun, and I hope immediately actionable. If you enjoyed the show, share it with a colleague, and remember, in AI, context is king, but structure is the kingdom. Catch you next time on AI on AI.